countdown before class starts. Just for fun. You'll remember from back in the day, and you can kind of jot this down, when we talked about transformations, there are three different, well, there's more than three, but there's three basic types of transformations we talk about. They are, and by the way, a transformation is just how one shape gets from one place to another. And the three different types of transformations were, we've got one right here, a rotation. We can rotate something, which is nothing more than spinning it about a point. We can translate it, which is a highfalutin word for slide. And we can reflect it, which is like looking in the mirror. But today, we're actually going to sit down and actually do some of that. In other words, take a shape and mathematically either rotate, translate, or reflect. And we're just going to walk through this because it can be kind of complicated, but it's not the easiest thing to explain, but it's not the hardest thing either. So let's look at el uno, merci. Danke. Danke schön. All right. What are we doing here with this first one, children? We are, what's it say to do? Rotate 90 degrees counterclockwise about the origin. What in the world does that mean, Emily Vaught? Yeah, that's what I thought. First of all, you want to look at what are you rotating about? It's getting rotated on this point right here. Which means if you stuck a pin in that paper and turned it on that point 90 degrees counterclockwise, I suppose we better go through that first. If you don't know what clockwise and counterclockwise are, it goes back to the analog clock. Maybe you've seen them before. Okay, the hands of a clock rotate this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is clockwise. If you're going backwards, it is counterclockwise. Okay. So what I'm doing with this one is I'm taking this shape, and it's like I'm putting a pin in there, and I'm taking the whole thing and rotating it 1/4 of a turn. They should always ask you to rotate something 360 degrees, Zach, right? Because if you rotate something 360 degrees, what do you get? The same exact thing. But this one we're not. We are going 90 degrees. So really what you think about is this. Okay, this axis right, this little line right here, if you turn it 1/4 of a turn, actually ends up being this line right here. Does it not? Which means this point, 1, 2, 3, 4, on that line, gets rotated. It's still on that line, except it's turned 90 degrees. 1, 2, 3, 4. This point here, what is that, a Z? Is that a Z?
Yes.
Gets turned, and it becomes this point here, which we're going to call Z prime, because it is Z and Z. So you've got that one point there. Let's go with the next easiest one. If you look at this axis right here, if I'm rotating it, it gets turned 90 degrees, so it becomes right here. Are you with me? And this point here, L, which is 1, 2, 3 away, is still 1, 2, 3 away, and it is right here. This is L prime. So now I've got two of the 3 points, right? L rotated 90 degrees and ended up there. Z rotated 90 degrees and ended up right there. How would I figure out where letter J prime is? Let's change colors for J prime. Well, let's go with hot pink. Well, really, it's kind of the same thing as when we spun the little red thing. If I still look at this axis right here and turn it 90 degrees, it's right here, right? Point J was what? 1, 2, 3, 4, 5 left and 1, 2 away from it, right? It's still going to be that same distance this way and this way from that axis. So you just need to count that. 1, 2, 3, 4, 5. 1, 2. There is your, what was that, J prime. And once you establish all of your points, then those of you that have straight edges, it would be nice if you did, but if you don't, I guess we can, what color should we make this? then you can just connect your point. You know, this gets connected. Oh, boy. L goes to J prime. J goes to L. And goes to that. You with me? That whole thing was spun and got put right there. Exciting? That's not confusing. You just kind of got to get used to it. Is there another reflection on? There's another rotation on this page. Reflect, translate. Is there no rotation? Is there another rotation on this? No. Is that the rotation? I hate to redo it. Is it just the? Wait a second. There's another page to this. Where'd it go? Huh?
Number 9.
Where'd my other page go? Number 9 is? There. Oh, yes. Graph the image of the figure using the transformation. Given. So, let's do this. Right now, you with me, problem number 9. First thing we have to do is graph this shape. 1, 2, 3, 4 points, and then see what happens if we rotate it 90 degrees clockwise about the origin. Here, let's do this. So, we've got negative 2, 0. Negative 2, 0 here, is it? Please tell me yes. Negative 2, 0. Then we have negative 4, 3. 1, 2, 4, 1, 2, 3. Is that there? Did I get that right? Stop me if you know I'm really making a mistake. Z, negative 3, 4. Negative 3, 1, 2, 3, 4. Am I right? Am I right? Negative 1, 4. Negative 1, 1, 2, 3, 4. Is that right? So there is my shape. Because you probably don't have a straight edge, I will draw these in here. Which point was this? Negative 3 something. Does your shape look like my shape? Now again, we are taking a pin, basically. You stick a pin in there and turn it 90 degrees clockwise, which is this way. You know, everything is just going to shift. Wait, can I do that? Hold on a second. Ladies and gentlemen, I think I have some sort of capability to do this. Ready? Oh boy. Check this out. Paste. Does that help you out? Give me a sec here. Am I still good? Let's try to get this the same size. A little farther. A little farther. A little farther. So let me just do this, and I think this will rotate it kind of about that axis. If I take this and spin it 90 degrees to the right, this is what it will look like. Now, of course, you can't tell what it looked like before. Okay, but that is what it looked like before. This is what our new shape will look like. Ooh, ah. So let's see how that looks. So here we go. Again, do this about the axes. Use the axes as your friend. In other words, define this point right here. This axis, if I move it 90 degrees, spin it 90 degrees clockwise, now becomes this line. And where is this point in reference to that? It's 1, 2, 3, 4 up, or out, and 1 up. So if I do that here, 1, 2, 3, 4, and 1, this point and this point coincide. What was that, x? It would be x prime. Same thing with this point here. How is it in reference to this? It's 4, 1, 2, 3. 4, 1, 2, 3. This point and that point, which is z prime. This point here, you're looking at this axis is 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. Am I good with that? And then this one should be easy because if I take this and I move this axis 90 degrees that way, it's just 2 up. It is 1, 2 right here. And then you can connect those dots. Anybody disagree with me? You can disagree with me. I've been wrong before. Does that look about like what we had over here? Anybody? You don't make this very easy, by the way. See how when I spun it 90 degrees, I ended up with that? Remember, it went from this to that. What happened to the days when we used to get a good ooh and an ah? I miss those days.
I know.
Joseph, one of these days, right?
On.
Now, let's move on to translations. Translations are by far the easiest things to do because you just have to pick the points. You just have to pick the points and do what it says. From every point, you go 4 units to the right and 1 unit down. So if I want to translate point F, I just go 1, 2, 3, 4 units to the right and 1 down. There's my new F prime. Rotation is really by far the hardest. Letter G, 1, 2, 3, 4 to the right, 1 down. So there's my G prime. Y, 1, 2, 3, 4, and 1 down. And there is my shape.
How would G be that far?
I don't know. What did I do wrong? Did I go 5? 1, 2, 3, 4, 5. How about you? I'm sorry. That was literally the first mistake I've made in this class today in the last 5 minutes. Is that better? Zach, do you agree with me now?
Yes.
I'm glad you caught that. Just makes you feel like you're being wrong. I don't think you should have any trouble with translation. Yes? No? Anybody? Now the hardest, the hardest was rotation in my mind. We have reflection. No. Oh. Translation, reflection. Here we go, ladies and gentlemen. Reflection. You ready to be amazed and astounded? You just have to look at what you're reflecting across, and we are reflecting across what?
The x-axis.
Why?
Sensor.
Okay, it's the x-axis. So if I were you, I would make whatever my reflection axis a dashed line, so just so I keep it straight. So this is the x-axis, so I would just go like this, because I know this is my reflection point. And from that, you just have to think about making perpendicular lines. Perpendicular lines. Okay? Because to find the reflection of C about that line, you just have to think about this. You think about this line. If you go perpendicular up to C, you go the perpendicular and opposite, I should say. If this is 1 unit up from there, you just go 1 unit down from there, and that is your C prime point. If this is your letter J, it's again up 1 away from that, so you go opposite down 1 away from it. That is your J prime. See point M? What do you do from the line to get to point M? You go down 2. So the opposite of going down 2 is to go up 2. Here is this point reflected. Point K, you go here, you go down 1, 2, 3, 4. So you go opposite and go up 1, 2, 3, 4. And that's K prime. Those are all of your reflection points. Connect the dot, Z. You end up with this here shape. And that is a reflection about the x-axis. Is there a harder reflection there somewhere?
Yes.
Where?
Oh, on the paper.
Now, take a look at this one. Because on problem number 6, it says to give the rule for the transformation. First of all, establish what type of transformation is 6? Is it rotation, reflection, or translation?
Reflection.
Yeah. It would not be translation because translation, the shape has to stay in the same orientation. Rotation means you'd have spun it. Did I spin this? No, because if I spun it, this little point would end up somewhere over there somewhere. So it's a reflection. Where is it being reflected? Really, you just have to think about this. How did I go from D to D prime, E to E prime, I to I prime, boom, boom, boom. And then think about drawing a perpendicular line through the exact middle of where those dashed lines gave you. So what is your reflection? Let's write that out. The reflection, it's reflected about what? How would you tell someone that this is, oh boy, Wade is leading with the paper. How would you tell somebody that that's your line of reflection? Does anybody know what that's called, that line right there? How do I know what that line is? What is it? This is where x is what? What is x right there? Oh boy, I got time. Here's your origin. X is 1, x is 2, x is 3. X is 3. Because it doesn't matter what y is. Remember we talked about x equals 3 is a vertical line. It goes way clear. So far so good, I can tell. Nobody's making any sense out of anything. Oh wait, do you need graph paper to be able to do this? Somebody say yes.
Yes.
Maybe. Let me see what we got here. Oh. How would you know what? Are you supposed to do number 7? What is the reflection point for number 7? Anybody?
X. No, that. X.
What?
It's Y. It's X.
What is x?
The reflection point is X.
Well, it's the x-axis.
Yeah.
Technically, it's where y is 0, but it is the x-axis. Now, how about letter number 8? What's the reflect? Oh wait, is that a reflect? There's a good question. What is problem number 8, children? Is it a reflection or is it a rotation? Right. How do you know it's not a reflection? Because not all the lines go. Ooh boy! Not all the lines go perpendicular to each other. If we look at how B goes to B like this, G goes to G like that, and X goes to X like that, there's no way you can get a line drawn between all that. So it is a rotation. What is the rotation? What happens to G? Look at point G. G went from here and went to there. Aaron Murray, how did it rotate? How many degrees did it rotate?
180.
Yeah. It is a 180-degree rotation. About what though? What's the middle? What is the middle point of the rotation? It is the origin. And I think they'll keep giving the origins. Somehow I got to get you a piece of graph paper though. I want you to do the last 4. Wait, do you have graph paper? Wait, homework paper has graph paper on it. You can do it on there. Wait. I would like for you to give the last 4 problems on there. There you go. I'll tell you what. I will take 1 away. I'll take 14 away. I want you to try a rotation. I want you to do a reflection, and I want you to do a translation. You can just use a piece of homework paper because it is completely full of grids and graphs.
Give me one.